Okay, guys, we're going to get going here with lesson 2, chapter 5. This is all on probability and odds, so it combines what you learned the other day with odds, and now places that with some probability, which is kind of what we're talking about throughout the rest of this unit. Okay, so we're just going to build off of that. So a quick review of what odds are. Remember, odds are a comparison or a ratio of one event versus the event not happening. So we talked about that the other day with the odds of one event happening versus another. Now we're just going to take that and build it as a ratio for probability. All right, so you're taking what you already have and you're just going to rewrite it another way. Okay, so for example, one here, research shows that the probability of an expectant mother selected at random at having twins is, or I should say, 1 out of 32. Determine the odds for and against having twins. Okay, cool. So this one here gives you the probability. Okay, this here would be your prob of the event happening. So the likelihood of having twins is 1 out of every 32. Okay, so we want to now write that as odds. So that would be, remember, your ratio for probability is 4 and against. So, and remember for probability here, it's what you want out of the total. And it's a simplified version. Kind of watered it down for you guys so you don't hurt yourselves. That's what I'm trying to get at here. So, what are the odds of having twins? Well, we know it's 1 out of. Now, the total was 32. So if we've taken one of those and had twins, the total against not having twins would be 31. Okay? And then what are the odds against having twins? Well, you would just switch that around. For the event not to happen, it would be 31 times, and then the time that it wouldn't happen would be 1. Okay? Any questions about that? Of course not, because I'm here recording by myself. Now, let's go on to question 2. I don't know what this record thing here is on the bottom, but we'll just keep moving along. It should move. All right, cool. Example 2. A computer randomly selects a university student's name from the university database to give an award of a $100 gift certificate, maybe like an iTunes reward, or maybe $100 to like a fancy restaurant like Montana's or Boston Pizza. All right. Oh no, it's for the bookstore. I should have read the whole thing. Cool. All right. You're gonna spend $100 at the bookstore. Now, the odds against the selected student being male are 57 to 43. Determine the probability that the randomly selected university student will be a male and the probability that it'll be a female. All right. So the odds against the selected student being male are 57 to 43. So what that means is there are 43 males and there are 57 not males. So that would make them female. Remember, the question said the odds against being male. So that would mean this is not male here. If it was odds for being male, then the first number would be the males. So that means out of a total of 43 plus 57, don't use your calculators, there's 100 students altogether. Okay, so this is our total. Total males and not males. So now we want to determine the probability that the randomly selected university student will be a male. So you write it like this, put P for probability, then you put brackets for what you want. So probability of M for male would be, remember this is what you want over your total. What you want is 43 out of 100. So you could leave it like that, or you could put it even, get fancy, as a decimal. Hopefully you don't need a calculator to do that. And then the probability that they will be female. Probability female, so what you want is all the women over your total. Or you could write it as 0.57 as well. Up to you, your call. All right, I don't care either way. If you are going to leave it as a fraction, though, like this, you put on your adult pants and you got to simplify the fraction. All right. 57 over 100 doesn't simplify anymore because one's an odd number, one's an even number, so you would just leave it like that. Okay. So odd equivalence now. Okay. You know what? We're not doing odd equivalence. That was something that used to be in. Now it's out. Moving on. Example 4. Guys, we're flying. Making such a good time. Okay, for example 4, a hockey game goes into a shootout. Dun, 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 dun. The coach has decided which player should go in first for the shootout. The coach wants to use the best shooter first. So clearly they're not going to pick Connor or Brody. So it'll be based on the player's shootout record. Player 1 has 13 attempts and 8 goals scored. And player 2 has 17 attempts and 2 goals scored. So now what we're going to do is we're going to write the odds in favor of each player's scoring ratio. Okay, so for A, in favor of each player scoring. So for player 1, we'll put P1. Out of 13, he had 8 goals. So he had 8 for, 5 against, right? I hope I don't need to explain that. 13 take away 8 was 5. Okay? Then for player 2, we know we got 17 attempts and 10 goals, so it's going to be 10. 10 for and 7 against. Now, let's look at this here. Write the probability of each player as a percentage. So B, probability of P1, we know it's going to be 8 out of 13. 8 divided by 13. Oh, I don't have a calculator. Works out to 0.62. Always go to 2 decimal places with this stuff, you guys. For the first little bit especially. And the probability of player 2, that's going to be, only scored 10 out of 17. .59. All wanted each as a percent, so this would be 62%, and this would be 59%. So now when you look at these, which player would you choose to shoot first? Well, that's hopefully obvious. Clearly, player 2 scores 60, or player 1 scores 62% of the time. Player 2 only scores 59% of the time. So you're going to pick player 1, right? P1 will shoot first. And it says, which one is easier to compare, odds or probability? I would make the guess that everyone's going to say seeing it as a percentage makes it way easier. Because what a lot of people do is they look at this and they say, well, he scored 10 goals. That's way more than this guy, and he also took more attempts. So that's got to be a good thing. But when you think about it, he scored more, but it took him more attempts to get there. That indicates that that's why he would have the lower percentage here. All right? So that's how the good example of why probability is a little bit easier than odds. most people do have trouble doing the odds section of this unit. So, all right, well, where do we go? All right, last example. A group of grade 12 students are holding a charity carnival to support a local animal shelter. Isn't that sweet? The students have created a dice game that they call BIM and a card game that they call Zap. Now, the odds against winning BIM are 5 to 2, and the odds against winning Zap are 7 to 3. Which game should you play if you love to win? Okay, so the odds against winning, so this would be the odds of losing. All right. So that means for probability of BIM. So what that means is you're going to, for BIM here, these are your losses, these are your wins. If you want to win, you get 2 wins, that's a total of 7. And then your probabilities of winning that. Zap, these are your losses. These are your wins. Now remember, it's because it's against winning. That's why the wins are second. All right? So it's going to be 3 out of 10. So now, write it as a percentage so you can see the numbers real quick. 29%, and this one's going to be 30%. So the probability of winning is actually greater with good old zip, zap, zippity, zop. All right? So this is the game you should play, even though you only have a 30% chance of winning, which makes sense when you think about it, because carnival games are rigged. Okay? They're run by those filthy, dirty carnies. All right, so that's what I got here for you guys today. Just be careful with the odds for and the odds against stuff. That really can trip people up. So your assignment is on page 310. I want you guys to do from 4 to 15. But no lying, just do it.